right, Module 4, Homework 1. We are rationalizing radical expressions. So what does that mean? That means when I'm dividing and there is a radical in the denominator. I want to rationalize it. So that's writing an expression without a radical. To do that, we're going to recall that the square root of 3 times the square root of 3 is the square root of 9, which is 3. Okay, so that's how we rationalize denominators, is we multiply by itself. So when there's one term in the denominator, we're just going to multiply by itself. So rationalize square root of 7 over square root of 2. What happens if we multiply by the square root of 2? Both the top and the bottom. Here's what happens. 7 times 2 under the radical is 14. Square root of 2 times square root of 2 is square root of 4. And the square root of 4 is 2. We don't have a radical in the denominator anymore. And that is our end goal. So we don't want to have a radical in the denominator. That's the whole point of us doing that. So we get square root of 14 over 2. So your process for rationalizing a denominator, you can simplify first or last. I actually like simplifying at the very end. I like to multiply first because then you don't have to simplify twice. See how it's there in 1 and 4? Just go straight to step 2, multiply the top and the bottom by the denominator, the square root of it. Multiply straight across, then simplify. So for example, okay, square root of 25 over x. Break that out into numerator and denominator. Now this one, you simplify that, that's easy. That's just 5. When I say wait to simplify, it's if it's like the one down here where it's not a perfect square. Perfect square, that's easy to simplify. Okay, then we multiply both the top and the bottom by the square root denominator. So square root of x, square root of x. So the top just becomes 5 times the square root of x. Square root of x times the square root of x is the square root of x squared, which is x to the 2 over 2, which is just x. So we get over x. And then I can't simplify those x's because one's under a radical and one's not. That's it. All right, let's look at example 2. So this is 5 over square root of 63x. So we can simplify 63, but let's just leave it like this for now. So I'm going to multiply both the top and the bottom by the square root of 63x. Okay, this is going to give me on the top 5 root 63x. On the bottom, you're going to get just 63x because 63 times 63 is 3969, and the square root of that is 63. And then x times x is x squared, which gives you x. So this will be a regular 63x. Now we're not done here because this 63 under the radical, I can simplify that. So I need to simplify my 63. What perfect square goes into 63? 9. 9 times 7 gives me 63, so that will give me a 3 root 7. Okay, which means I have this for my numerator now. 5 times 3 root 7x. 5 times 3 will give me 15. And I put that over my denominator, 63x. Now, is that fully simplified? What do we want to do here? Yeah, couldn't I take these? This is just a normal fraction. 15 over 63, right? I can reduce that. 15 divided by 3, 5. 63 divided by 3, 21. So that's going to give me a 5 root 7x over 21x. Now we are fully simplified. All right, so that's when there is one term in the denominator. When there are two terms in the denominator, you are going to do a different process. You're not going to actually do the process. This is just going to be questions of like, what should you do? When you get to college algebra, then you'll go further with this. Okay, so this is saying rationalize with two terms. So in this denominator, you have 1 minus the square root of 5. If you multiply by just the square root of 5, look at what happens. You get 8 root 5 over square root of 5 minus 5, which means what happens is you still have a radical in the denominator, so it doesn't work. So when you have two terms in the denominator, you're going to do this. You're going to multiply by the conjugate, or the complex conjugate is what that is. All you do is you change the sign in the middle. That's it. So the conjugate of 1 minus root 5 is 1 plus root 5. So you're just going to have homework questions that are asking you what the conjugate is. So if we look at that example now, just for you guys to see, again, you're not going to have to do ones like this. You had 8 over 1 minus the square root of 5. If I multiply by the conjugate, you will be able to get rid of the radical. Okay, what's going to end up happening here is you're going to distribute the 8. You're going to get 8 times 1 is 8 plus 8 root 5. Okay, then let's take a look at what happens in the denominator. So in the denominator, you're going to go 1 times 1 is going to give us 1. 1 times root 5 is going to give us plus 1 square root of 5. Negative square root of 5 times 1 is going to give us negative 1 square root of 5. And negative root 5 times positive root 5 is going to be negative square root of 25, 5. What ends up happening are these guys cancel out. And I get 1 minus 5, which gives me negative 4. So my radical is gone from the denominator. So then this problem looks like this. 8 plus 8 root 5 over negative 4, and then I simplify that. 8 divided by negative 4 is negative 2. 8 divided by negative 4 is negative 2 root 5. Okay, again, you're not going to have to do ones this complicated. You're just going to be answering the questions, what is the conjugate? But when you get to college algebra, chapter 1, you're doing this. Okay, so if I have my next example, what is the conjugate of negative 2 root 17 plus 5 root a? What would that be? What does it say to change in that big box? The sign. What sign? In the middle, this one. That's all you got to do. You don't change this sign just because it's negative. It's the same. You do change that plus to a minus. That's it. Okay, let's look at homework 2. This kind of goes along with our radicals. How many of you have done complex numbers before? How many of you have seen I in math before? All right, that's what we're looking at. So a complex number consists of a real part and an imaginary part. The real part being a, the imaginary part having the I. Your rules for I, in case you forgot, I squared is -1. I is the square root of -1. Okay, so it is actual number, that's what it stands for, square root of -1. Because we can't take the square root of a negative number. We can take the square root of 9, it's a positive number, 3 times 3 is 9. Or it could be -3 times -3. Okay, that would also be 9, so that would be okay. But because of our rules of multiplication, there are no two copies that are exactly the same that would give me the square root of 9, because -3 times +3 is the square, or is -9, but that contradicts the rules of square root, because remember, it's the same exact number. These are two different numbers. One of them is 3 units to the left on the number line, the other one is 3 units to the right. So we use I. What we're technically doing when we're doing the square root of 9, or -9, is we're taking this and we're doing a factor tree where we're factoring out a square root of -1 times 9. That way we can take the square root of 9 and get 3, and we have that the square root of -1 is I. So we do I times 3, which gives us 3I. Okay, or the easy way to do this, anytime you have a negative under the radical, what I like to do is I just take this, turn it to plus, put the I in front, take the square root of the number. Okay, but this is technically what's happening when you do that. Okay, you're factoring out that -1 so that you can take the square root, so you don't break the rules of what a square root actually is. So if we look at just a couple of problems here, you have negative square root of 16. There's no negative underneath the radical here. This is just -1 times the square root of 16, which is 4. So this is just -1 times 4. So -4. Okay, if it asks you to express it in terms of I, you're going to write it like it was on the previous page, where it was A plus BI. So that's what it's asking you to write all these answers as. If there's no I term, you're going to write it like this. I know it looks weird, but we're learning about complex numbers here. So there is no I term in this. We're just putting it in terms of I, -4 plus 0I. Now our second example, we do have a negative under the radical. Okay, so you want to factor out that -1. So like I said, a shortcut, take that minus, make it a plus, put the I in front of it. Square root of 25 is 5. So this is 5I. Again, write it in terms of I. So now this doesn't have a whole number. So 0 plus 5I. Okay, and the only reason I'm showing you this, I think if you enter it on your homework just as -4 and just as 5I, it's fine. But some of the multiple choice on the test and on the final exam, from my recollection, will have the answer in this terms, and sometimes that confuses students. So I want you to see it now to get used to seeing it like that. All right, when we have a negative under the radical, we can still simplify. So in this example, I have the -18 under here. So I'm going to take this, make it plus, put the I right there. I'm going to rewrite that so I don't forget that I had an I. Now I can simplify that 18. Do I have a perfect square that goes in? 9 times 2. So that's going to give me 3. And there's nothing in between here, so this is all times. Can I do 5I times 3? You can. You treat the I just like you treat an X. Okay, so you can multiply. You just multiply the numbers, 5 times 3, and carry the I over. And then if you were writing it in terms of I, if you saw that multiple choice, it might have a 0 in front of it. Again, entering it on MyLab Math, you should be fine with just this one. Okay, this next one is a little different here, because if I multiply -5 and -15 right away, I'm going to get a positive number. So do I multiply first or do I do the I first? What do you guys think? We're going to do the I first. Okay, so you want to pull out the I first before you do any multiplication. Okay, so if you see that, first thing is the I. Now multiply. I times I squared, 5 times 15, 75. What's I squared? Look back on the previous page. -1. So I squared is -1, so this becomes -1 times root 75. Can I simplify 75? Yeah, 25 times 3. Square root of 25 is 5. Bring down the -1. -1 times 5, -5 root 3. If I would have gone straight to multiplying first, I would have gotten +5 root 3. So I want to make sure that I do the I first so I get the correct answer. Okay. Next example, we are dividing. It's got radical in it plus a negative underneath here. So do the I first to make that plus, put the I in front of the 10. And then I want to divide. So I'm going to multiply both top and bottom by what? Square root of 5. We just did this last section. Okay, which means on the top, that's going to give me I, 10 times 5, 50. Let's go ahead and simplify that. We just did that one, right? That was 25 times 2. Square root of 25 is 5. So that's going to give me a 5i root 2. That's my numerator. What goes in my denominator? Square root of 25, which is what? 5. So I just put this over a 5. And these 5s cancel? Yeah. So I root 2. Okay, and then this last little part here, we are doing operations. So adding, subtracting, multiplying. We're not going to divide until you get to college algebra with them. Okay, do the operation. You're treating I just like X. Okay, so adding, subtracting, multiplying, all the same rules as you would with a variable, except when you have I squared, it's -1. So example 1, I am multiplying. What do I want to do to multiply here? FOIL. Okay, so first term times first term would give me 3 times 4, 12. My outside terms, 3 times -3 would give me -9. Carry the I. My two inside terms, 2i times 4. 2 times 4 would give me 8. And I would carry the I. And then my last, 2i times -3i. 2 times -3, -6. I times I squared. Okay, I squared is negative 1. So this is going to become negative 6 times negative 1. What's negative 6 times negative 1? Positive 6. Okay, so my problem comes down like this. 12 minus 9i plus 8i plus 6. So I'm just bringing down these first three terms. Now I combine like terms. So I have 12 plus 6, 18, negative 9 plus 8. What's that going to be? Negative 1. Negative 1i. So just negative I. All right, example, we'll just go to example 3 here. This is subtraction. What do I do in subtraction with variables? Distribute what? Yeah, I distribute a negative 1 here. Good. So bring down 3 plus 2i, then distribute this negative 1. So it'll be minus 4 and plus 3i. Now what? Combine like terms. 3 minus 4, negative 1. 2i plus 3i, 5i. Okay, example 2, we are adding. So adding, we're just going to combine like terms, right? 3 plus 4, 7. Positive 2 minus 3 is going to give me what? Just negative 1, right? Negative 1i. Okay, and then last example, I am multiplying. So I'm just distributing this 2i. So 2i times 14, 2 times 14 will give me 28i. Then 2i times negative 8i, 2 times negative 8 will be negative 16, I times I squared. I squared will convert to a negative 1. So that's negative 16 times negative 1, positive 16. So I have 28i plus 16, which is fine, but you're probably going to see the answer like this. Okay, with the I last. Okay,